Okay, here we go with problem 4 from the chapter 1 review. And my contrast is I'm trying to work with it with the graphing calculator and the paper, and it's giving me a hard time, but let's see how it goes. So we'll try and make sure we can see what I'm doing on the graphing calculator, I hope. Alrighty, so this problem, it was written out in words, and I changed it to a picture. It says you have a triangle, PQR, and you know the length of PQ is 13.4, and the length of QR is 15, and the measure of angle P is 31. Find PR, so I labeled it X, by using the cosine rule. So here's the cosine rule, which is in your formula packet, or if you had just turned back one page in your textbook, you would have seen the cosine rule. And then it says for part B, do 2 applications of the sine rule. So I am going to, of course, do the cosine rule first. And I actually figured out kind of a fast way of doing this. So first of all, I know this is the only angle I know. So this is going to be my angle A. So that means side A is the side across from it. So in our cosine rule formula here, this is going to be angle A. So this is going to be side A. Sorry, I should have used a capital A. That's going to be angle A. Side A is across from it. So when I fill in my values here, I'm going to have 15 squared is equal to x squared. Doesn't matter which one is B and which one's C. It's just the other two. 13.4 squared minus 2 times 13.4 times x times cosine of A, which is 31 degrees. So notice we're in degrees. So make sure, oops, I'm off the edge. So make sure that your calculator is reading in degrees. Okay, now I could kind of try and simplify this, but hey, we got technology. Who needs to simplify it? I'm going to y equals, clear out whatever I got in there. All my x's are on one side of the equation, so I'm just going to put 15 squared into one of these y equals, so 15 squared. And sure, I could have multiplied it out, but why bother? We got technology to do that. All right, and then I'm going to just type this in. X squared plus 13.4 squared minus 2 times 13.4 x times cosine of 31. Okay, so I'm just typing it all in to the second y equals, and I'm going to graph it. I'm going to look for the intersection of those two lines. And of course, there goes the contrast. Let's see, I was doing this before, and it seemed to help. So I make it rethink about it and bring it back down. Okay, so first of all, 15 squared, what is that, like 225? So I know that my zoom is not going to be in standard form because this is a really big number. So my graph is probably way up high here, which you can't see. This is going to make me nuts this semester if I can't get the balance right on the brightness. Okay, there we go. So I'm going to do zoom 0 to try and get the intersection showing on here. So it's thinking about it. I can see the little thinking icon there. It's thinking about it. I could have messed around with the window. I probably should have set this up ahead of time. It's thinking for an awful long time. La 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 la. Talk amongst yourselves. So much fun. Okay, I'm going to kill it because I think it's like having a hard time. So let's try that again. So graph, there we go. So sometimes you just need to turn it off and turn it back on again. And here it comes. Okay, so 15 squared is the blue line, and all this mess on the right-hand side of my equation is the red line. And I want to see where they intersect. So second, calculate. And I want number 5, the intersection. First curve, enter. Second curve, enter. Guess, enter. And it gives me x is equal to negative. Okay, I can't have x be a negative, so surely there must be another intersection. So I see there's an intersection here, but I'm guessing that this is a parabola and it's going to come up on the other side. So I'm going to zoom out and let's move it over to the side here. I'm guessing that there is going to be another intersection because it can't be a negative because it's the length of a triangle. So we don't want the negative value. And sure enough, there it is. Can we see it? There it is. So I want that other intersection. Okay, so I'm doing the second trace to bring up my calculate menu, number 5 for intersection, first curve, second curve, guess. Oh, it went to the wrong one. So let's do that again. Second, calculate intersection. Let's move over to the other intersection. There we go. First curve, second curve, guess. And it tells me x equals approximately, because I'm going to round it off, 24.8, and that would be centimeters because we're talking about the side of a triangle. Okay, so I just used my graphing function. I just put one side of the equation for y equals and then the other side of the equation, and I got to see where they cross. Nifty. Okay, if you can write an equation, then you can enter in the two sides of the equation and just see where they cross to solve it. Bam, using technology. Okay, so there's the answer to A. You also could have tried to simplify it and solve for x, but it would have been a quadratic, and you could have used the quadratic formula, but this was faster. Except that, of course, finding the right window size was a little bit challenging. All right, sine rule. Sine of angle A over A is equal to sine of angle B over B. So I know these two sides and I know this side. So I want to find this angle is what I'm going to be able to find. I'm not going to be able to find this side directly because I don't have the angle across from it. So that's why it said use 2 applications of the sine rule, because I do not have the side across. I don't have the angle across from side X. So I can't solve directly for X. But I do have this side, so I'm going to be able to solve for angle R. Okay, so I already called this A and A, so I'm going to call this, switch my colors again. This is going to be my angle B and little b. And then I can solve for this angle. Once I have this angle, I can then use the fact that the 3 angles inside of a triangle add to 180 to get that angle, and then I can do my second application of the sine rule to get X. So it's going to take 2 steps using the sine rule. That's okay, so let's give it a go. All right, so angle A is 31 degrees. So sine of 31 over 15 is equal to sine of B over side B, which is 13.4. Notice how I set this up. I wanted to have the unknown in the numerator, not the denominator, because if you look at how the sine rule is written in both formula packet and in the textbook, it can also be written upside down. You could flip both of these fractions. Okay, so I want to make sure my unknown is in the numerator. It just makes my life easier. Because to get sine B by itself, all I got to do is multiply both sides by 13.4. So I get 13.4 times sine of 31 over 15 is equal to sine B. I'm not going to simplify this yet. I'm going to wait until I've isolated angle B. So to get angle B by itself, I'm going to have to do inverse sine. So angle B is going to be sine -1 of this whole mess. 13.4 sine 31 over 15. Okay, the reason why I'm not simplifying this on my calculator and writing it down is because I might make a mistake writing it down. I also don't want to round it off at this point. I want to make sure I keep all the precision I possibly can until I'm writing down my final answer. That's when I round it off to 3 significant figures. All right, here we go. Let's go with this mess of a calculator that you're not going to be able to see the screen on. Oh, fingers crossed. Let's hope it stays like that. All right, so I'm going to do second sine to get my inverse sine, and then 13.4 times sine of 31, close my parentheses, divided by 15, close my parentheses again, and hit enter, and I get 27.3936. And I want all of that. I want to keep all of my precision at this point. So the measure of angle B, I'm going to switch sides here. Angle B is equal to 27.39360,441. We want to hold on to all of that precision before we go and use it again to solve for angle Q. Okay, so we now know angle B. Now we want to find angle Q. So angle Q, I just know that the 3 angles have to add up to 180. So I have, let's see, what have I got here? So I'm going to do 180. You see my calculator? 180 minus, see how I can select it, enter, and then minus, where's the other one? The other one was the 24.8. Oh, I know. I don't have it here because I got it from the graphing thing. So I'll just type it in, 24.8. So I probably should have written down more digits there. Oops, bad me. Okay. Oh, wait a minute. No, we don't know that yet. Sorry, what am I doing? Minus 31. Okay, pretend I didn't say that. Minus 31. Oops, 31. Delete. Okay, sorry. The two angles we know, and here we go with the contrast again. So I have 180 minus 31. I forgot, we don't know. That 24.8 was X. Sorry about that. Okay, so 180 minus 31 and minus angle B, which was 27.39360,441. I have that in my calculator. That's going to leave me with angle Q, which is 121.6063956. Okay, so now I have angle Q, and this is, oops, sorry, where am I? I'm off the bottom. There we go. Angle Q is approximately equal to 121.6. I'm going to keep the whole thing in my calculator because we're going to need it for the next step, which is finding X. Okay, so now that I know that Q is approximately 121.6 degrees, I can now set up my sine rule again. So I'm going to do it again, and I'm still going to use the sine 31 and 15, but this time I'm going to flip it upside down because now I'm looking for a missing side. So my missing side is X. It's across from this angle, so sine of 121.6, but when I put it into my calculator, I'm going to use the whole thing that is stored in here, is equal to 15 over sine 31. Okay, to get X by itself, I need to multiply both sides of the equation by sine 121.6. So I get X is equal to 15 times sine 121.6, all divided by sine 31. And then here we go. I'm going to put it into my calculator. Let's see if we can see that. 15 times sine, and I'm going to go up and select it to put it into my calculator. There it is, close parentheses, divided by sine 31, enter 24.8, which is the same answer I got, much easier just using the cosine rule. Okay, so there is a review of the cosine rule and the sine rule. And so these are nice for non-right triangles. If you have right triangles, then of course you would just use Pythagorean theorem and basic right triangle trig, SOHCAHTOA. But for non-right triangles, we've got the sine rule and the cosine rule. Okay, and that's it for number 4. How do I stop my recording? Bear with me. Bye.